Hello everyone, today we are beginning Unit 10 on 2D geometry. Starting in Section 1, we have area of triangles and quadrilaterals. So here we have a bunch of area formulas for each shape, and I'm going to zoom in so you can see them better in just a second. And I'm going to mention that you should already know what each of these shapes are, but we'll cover that a little bit in detail as we go. So starting with a triangle is a shape that has 3 sides and 3 angles. When we find the area, we use area is equal to 1/2 the length of the base times the length of the height. Now the base is the lower side of the triangle. The height is the distance, the vertical distance between the peak of the triangle and the base. So it is most likely going to go through our triangle, but if it is a right triangle, then it is going to be the length of one of our sides. Next we have a rectangle. A rectangle here, we have 4 sides, our opposite sides are congruent and parallel to each other, and we have 4 right angles. And we use the base and the height. So area is equal to base times height, where height will for sure be one of the sides and the base will be the other. Next we have a parallelogram. A parallelogram is a shape that has 4 sides and opposite sides are parallel to each other, and our angles do not have to be any specific degree. So that's the difference between a rectangle and a parallelogram. Rectangle has to have 4 right angles. Parallelogram, it doesn't matter what those angles are, but our sides do have to be congruent and parallel. To find the area of a parallelogram, use the same formula as a rectangle. Area is equal to base times height, where the base is still the bottom side of our shape, but the height is no longer going to be the side of the shape. Now, it could be if it was specifically a rectangle, but if it is not, then you have to go the vertical distance between our 2 bases. So this would be the top base and our bottom base. All right, I'm going to go down to a trapezoid because the trapezoid also has 2 bases. We have the top base and the bottom base. Our 2 bases do have to be parallel, but they do not have to be congruent. In fact, most of the time they aren't congruent, and typically the first base will be quite a bit shorter than the second base. And then our sides will connect our 2 bases at an angle. So we have, for the area of a trapezoid, area is equal to 1/2 times the sum of our bases times the height. So you have to add the bases together first. So the length of the top side plus the length of the bottom side, divide that by 2, multiply that by the height. And the height is again the distance between our 2 bases, the vertical distance between our 2 bases, not one of the side lines. All right, next we have a kite. A kite is found with the formula area is equal to 1/2 times P times Q, where P and Q are the length of our diagonals of the kite. So that is the length, the distance between our 2 peaks. We have this shorter length between these 2 vertices and this length between our further 2 vertices. A kite has 2 sets of congruent sides. We have one right here, and then the other is right here. And then last we have a rhombus. A rhombus uses that same formula because a kite is a type of rhombus. And we have area is equal to 1/2 times P times Q, where again it is your diagonal P and diagonal Q. It's those 2 lines that connect our vertices across the shape. So now that we've looked at all of those formulas, we are going to do a few examples. So example 1 says to find the area of each shape below. So I'm going to start right here with this parallelogram. To find the area of a parallelogram, I use that formula. Area is equal to base times height, where my base is marked as 8 and my height is marked as 6. So the area of this shape is equal to 8 times 6, or 6 times 8 is 48. So this is 48, and our units are given as meters, and because we are multiplying 2 things together and it is area, then those are going to be square meters. Next I have this trapezoid here. The formula for the area of a trapezoid is 1/2 times our bases added together times the height. So in this shape, I'm given one base as 15, a second base as 11. So I have 1/2 times 15 plus 11. Then we multiply that by the height. Now, sometimes the height is going to go through the middle of the shape, but in this case, we have a right angle over here. So our height is just going to be this side, which is 7. So first I'm going to add these two pieces together. 15 plus 11 is equal to 26. So that's equal to 1/2 times 26 times 7. Half of 26 is 13. So what we really have is 13 times 7. 13 times 7 is equal to 91. So I have the area of this trapezoid is equal to 91 meters squared. Next I have a kite here. The area of a kite is equal to 1/2 our diagonals multiplied by each other. So I have AC marked as 14 centimeters and BD marked as 10 centimeters. So all I have to do is plug in place for P and Q my 14 and my 10. So I have 1/2 times 14 times 10. If we want to make this nice and easy for ourselves, half of 14 is 7. 7 times 10 is 70. So I have my area is equal to 70 centimeters squared. Next I have a triangle. The area formula for a triangle is area is equal to 1/2 times base times height. My base is marked as 4 and my height is marked as 6. So I have 1/2 times 4 times 6. Half of 4 is 2. 2 times 6 is equal to 12. So the area of this triangle is 12 centimeters squared. Example 2, we're continuing with finding area. We have the area of this triangle here, and we have the area of this trapezoid, both of which are going to be using a variable. So let's start with our formula over here. Area is equal to 1/2 times base times height for a triangle. So in this case, my base is unknown. It is still B. I do know this side. In this scenario, we actually can solve for our missing side because we know the Pythagorean theorem. So I have 12 squared. I'm going to actually write this to the side over here. So I have 12 squared plus B squared is equal to 20 squared. So 12 squared is 144 plus B squared is equal to 20 squared, and 20 times 20 is 400. Then we'll subtract 144 from both sides. Then I have B squared is equal to 256. We're going to square root both of those sides, and that gives me that B is equal to 16, and that's meters. So now I can take that and I can plug it into my formula. So area is equal to 1/2 times 16 times our height of 12. Half of 16 is 8. 8 times 12 is 96. So area of our triangle is 96 meters squared. Next we have this trapezoid here. This one is not going to work as nicely for us where we can just create a triangle and solve for our missing side. So we're going to have a variable in our answer. So my formula for a trapezoid is area is equal to 1/2 times the first base plus the second base, all multiplied by the height. So my bases in this case are 7.2 and 4. So that is equal to 1/2 7.2 plus 4 times our height, which is 3x. Because we have a right angle, that makes that the height. So 7.2 plus 4 is equal to 11.2. So I have 1/2 times 11.2 times 3x. Half of 11.2 is 5.6. So I have 5.6 times 3x. 5.6 times 3 is equal to 16.8. So I have the area is equal to 16.8 x feet squared. All right, moving on to example 3. We have find the base of a parallelogram in which the area is 28 square yards and the height is 56 yards. So we know the area formula for a parallelogram is area is equal to base times height. If we already know that the area is 28 and our height needs to be 56, then we can figure out what b is from that. So I have, now I'm thinking about it, this is supposed to be 5.6, not 56. So let's change that, that's 5.6. So then we have area is 28 is equal to the base times 5.6. So we're going to divide out 5.6 from both sides. And when I divide 28 by 5.6, that gives me that my base is equal to 5 yards. All right, example 4. This time we're trying to find the height of a triangle whose area is 15 square centimeters and has a base of 5 centimeters. So I have my area formula is for a triangle 1/2 times base times height. So I'm going to plug in what I do know. I know my area is 15. That's equal to 1/2 my base, which is 5, times the height. So I'm just going to go ahead and simplify. So I have 15 is equal to half of 5, which is 2.5, times the height. Divide out 2.5 from both sides. That leaves me with my height as 6 centimeters. All right. Next we have example 5. It says a kite's diagonals are perpendicular. Knowing this, find the area of the kite below. Okay, so let's zoom in on this kite here a second. And we know that these are perpendicular, so we have 4 90-degree angles here. If these are perpendicular, and some things that I know about bisected lines and perpendicular angles is that we're going to be able to use some of our triangle knowledge to solve for our missing pieces. So if we know that this is a right angle, this is our short leg, this is our long leg, and this is our hypotenuse. So we can use the Pythagorean theorem to solve for y. So I have a squared will be my y, so I have y squared plus my b squared, which is 28, is equal to my c squared, which is my hypotenuse of 35. So 35 squared. 28 squared is equal to 784, and 35 squared is equal to 1,225. Going to subtract 784 from both sides. And that gives me that I have y squared is equal to 441. I still need to get y by itself, so I'm going to square root both sides. That gives me that y is equal to 21. All right, so now that I know my y is 21, I can use that information to solve for x by using the Pythagorean theorem again, because now we have a different right triangle. We have our short leg, our long leg, and our hypotenuse. So I have x squared plus 21 squared is equal to the hypotenuse squared, which is 29. 21 squared is 441. We already know that from when we found the square root of 441. And then 29 squared is equal to 841. We're going to subtract 441 from both sides. In doing so, that gives me that x squared is equal to 400, and the square root of 400 is 20, so x is then equal to 20. Okay, so now we found x and y, but you might notice that there's actually a piece that we're missing still, but because kites have two sets of congruent sides,
it actually makes it so that we have two sets of
because we know
congruent
these
triangles.
sides are congruent, and this is 28 in both pieces, and these are both 90-degree angles, we have two congruent triangles. So this has to be 21. All right, So then to find our area, you need the full length of our diagonals. So we have 20 and 28, and we have 21 and 21. So I have 21 plus 21 equals 42, and then I have 20 plus 28, which is 48. So in my area formula, I have area is equal to 1/2 times P times Q. Now that I know my full diagonal lengths, I can plug those in for my area formula. So I have area is equal to 1/2 times 42 times 48. Then I'm just going to type this right into my calculator, and that gives me that the area of this kite is equal to 1,008 square inches. All right, so that's example 5. Now, if we look at example 6, we are working with a rhombus, and it says that the diagonals of a rhombus are perpendicular bisectors. So one of them is not drawn in there. We need to draw the other in. So that's going to come right through here, and that's creating these 90-degree angles because they're perpendicular bisectors. And because it says they are bisectors, and that means that our halves are going to be congruent as well. So whatever this is, this will be that same value. Whatever this is, that will be the same value. Now, it did tell us our horizontal distance was 72, so I don't actually need to cut those in half to find my diagonals, but it will be helpful to help me find the other diagonal. So half of 72 is equal to 36. So this distance here is 36. And that's helpful because I do know the hypotenuse of this triangle, and now I know the long leg, so I just need to find the short leg. And when I find that short leg, I can double it to get the full length of my diagonal on my rhombus. So I have my unknown side plus unknown side squared plus 36 squared is equal to 39 squared. 36 squared is equal to 1,296, and 39 squared is equal to 1,521. We still need to get x by itself, so I'm going to subtract 1,296 from both sides. In doing so, that leaves me with x squared is equal to 225. We're going to take the square root of both sides, and that leaves me with x is equal to 15. Now that I know halfway across, I know the full length because I can multiply that by 2 to get my full distance. So 15 times 2 is equal to 30, and that is the length of this whole piece. That's 30 meters. So now the formula for the area of a rhombus is 1/2 P times Q, so I have 1/2 30 times 72. So let's write that out. Our formula is 1/2 times P times Q, which is equal to 1/2, in our case, 30 times 72. I'm again going to type this in my calculator, but what I'm really going to type is 15 times 72, which gives me that the area is equal to 1,080 square meters. All right, that is where we're going to stop for today. We'll pick back up in section 2, which is going to cover circles.